So we've been talking about probability distributions and random variables. And we're going to just talk about two types of probability distributions that commonly occur. Okay? One is called geometric, and the other is called binomial. And we're going to use both. We're going to talk about both using this example. So we're going to talk about free throw shooting. Because there were some NBA players who played during a time, like in the 60s, when they would take free throw shots underhand. Okay? And then they changed to overhand. So you can see here's one player, Wilt Chamberlain, who actually his free throw accuracy was over 61% when he shot underhand, but under 50% when he shot overhand. And yet he changed to overhand. Okay? So why did some of these guys stop shooting underhand and go to the overhand, even though it didn't seem to be helping them? It made it worse. Okay. So the geometric distribution would answer a problem like, how many you shoot free throws until you make one. So we would answer questions like, what's the probability that you would keep shooting free throws until you made the fifth one? Okay, so the value of the random variable is 5. What is the probability that you keep shooting free throws until you make it on the third try? What is the probability that you make it in 4 attempts or less, your first shot? Right? Things like that, which you guys should be able to answer with what you know already about probability. So here, he keeps shooting granny style. So he's shooting granny style this time until he makes one free throw. Each shot is independent, which means how you did on one shot doesn't change your probability on the next shot. And remember, the probability was 61.3%. What's the probability that he makes his first, or that his first make is on the 5th shot? So what we're doing, if we call the random variable x, we want to find the probability when x is 5. Okay? So think about what you know about probability. He's not making it until the 5th. So what's the probability that on the first one he misses? 39.7? 38? 0.387? Or yeah, I'm going to write it as a decimal. Because when we do calculations, we don't use percent, we use decimal. So that's the probability that he misses on the first one. What's the probability that he misses on the first and misses on the second? And times misses again. Because he doesn't make one until the 5th. So on the third one, he misses. So what's the probability of missing and missing and missing? Times 0.387. Same with the fourth one. The only time I change it is when he makes it on the 5th one. So this would calculate his probability that he misses the first 4 and makes the 5th. Yes, I was just going to say, you obviously want to do that. Because that's much more efficient. That is a much more efficient way of writing. And that works out to approximately 0.014 or about a 1.4% chance. Okay. So how do I know, like this is This is a random variable problem, a probability distribution problem. But how do I know it's geometric? The key to recognizing a geometric is asking about when the first success is. And you're doing an unlimited number of trials until you get a success. So I could have said, what's the probability that he makes it on the 15th try, the 100th try? It just keeps going until we define when a success is. So a geometric distribution, how do you recognize one? There's actually 4 different situations, okay? And you can think of the word diffs. First of all, B stands for binary outcomes. One of 2 things happen. It's either a success or it's a failure. So in the first shot, it's either a make or a miss. Each time you do one, the probability is independent of each other. So independent trials. The probability of the first time does not influence the probability of the second trial, which doesn't influence the probability of the third trial, etc. We are looking for first success with F then. F stands. And every time there's a trial, the probability is always the same. Like in that previous example, the probability of missing was always 0.387. The probability of making was always 0.617, 613. So here's a, yeah.
Sorry. First probability that he misses the third attack, would that still be a geometric distribution?
That would be more of just a probability distribution, because that's not looking for a success. That's looking for a failure. Okay. So here's a formula that we can always use to calculate geometric probabilities. Okay. We always take the number of failures, like P represents the probability of success. So it's the probability of failures, how many of them before the first success. So if we looked at that free throw again, and let's say I'm going to make it smaller just to make the numbers easier. The probability that he makes it on his third attempt, well, that means he doesn't make it on his first 2, 1 less. So 3 minus 1. And then he makes it on the attempt after that. That's what it looks like. That's when we're finding an exact number for the success. What about if we're finding a range? What about what's the probability that he makes it on his third attempt or earlier? That's the difference between probability density function and cumulative distribution function. We're talking about a specific value. We're talking about a range of values. So we have to do, okay, what's the probability when X is 1? Add that to the probability when he makes it on the second shot. Add that to the probability that he makes it on the third shot. That's a lot of calculations. Right? Because here, if the probability of the first shot would simply be, well, he makes it on the first, so it's this. The probability of the second is he misses and then makes. And the probability of the third is he misses twice, then makes. So you can see that's a lot of calculating. This is a formula you'll always get, but the nice thing is, oh, before I go to that. So the difference between the two, what's the difference between PDF and CDF? Okay. PDF looks for an exact success number. What's the probability of making it on the third, the fourth, the 10th? CDF looks for a range of success numbers. So what's the probability of making it on the third or less? The probability of making it on the 9th or less. Now, like I said, you've got a formula that you can use, and you can kind of use intuition to figure it out. But the nice thing is, there is a graphing calculator function, or functions. Okay? So, if we take the same situation above, 3, what's the probability that he makes it on the third? What's the probability that he makes it on the third or earlier? So first thing you have to do is recognize, is it a PDF or a CDF? And then what you do, because it's a distribution, you go second bars. That's distribution. That's where we always find normal CDF when we did normal calculations. Hello? Scroll down until you hit Geomet PDF. It'll be at D. Or you can just scroll up from the screen, and I think it takes you there quicker. And remember, you want Geomet PDF for this one. So you select that, and then it's asking for 2 values. The probability of success, which you enter as 0.613. And what number of the random variable are you looking for success on? The third one. So 3, paste, enter. It's gonna give it to you in parentheses. You hit enter again and it gives you the decimal probability, which should be 0.092 if you round it. Okay. Yep.
Does it always be constant decimal?
Yes, not a percent. Because remember, we don't calculate on calculators with percents. We always change them to decimal. So you should get, hang on, 0.092 or 9.2%. So there's a 9.2% chance he makes it on the third attempt. Yep. Brooke?
I was looking for the keyword I should look for.
Oh, yes.
Yeah. Inverse binomial.
Binom, no, Geomet. Geomet PDF.
Okay, I have an entrance of following. And
So the probability of success is 0.613. And the value of the random variable we're looking for is the third attempt, 3. Anna?
yeah.
The whole thing. Everything. Yes. Yes.
If we wanted to find it on the third attempt or earlier,
Well, first of all, do you think the probability is going to be higher on this one? If he gets it on the third attempt versus the third attempt or earlier? On this one, right? Because, I mean, really what happens is the probability of getting it on the first attempt is the highest. And then it goes down after that. Okay, that's actually, you could actually draw a bar graph and it would look like this. That's actually what a binomial distribution would look like. So this one, remember, everything else, everything's going to be the same, except you got to choose CDF. And you're still going to enter 0.613 for the probability of success and 3 or lower. And then you have to enter a couple of times, and you're going to get a very high probability. 0.942 or 94.2%, which actually makes a lot of sense. Okay. Yes. Yeah, always success.
Your final answer, do you
Not really, no. 1 decimal place, 2 decimal places. Whole number. Is that? A random variable distribution we're going to look at is something called the binomial. And here's the difference. Going back to the free throw shooting example, this would be a binomial question. You shoot a set number and count how many you make. So it's not the first success. It would be like, okay, you shoot 10. What's the probability that you make 5? What's the probability that you make 8? What's the probability that you make 4 or fewer? That's the difference between the two. Okay. So here, we've got a fixed number. He's not shooting until he gets a success. That's an infinite number of shots, potentially. Okay. He's only shooting 8. I want to know what's the probability that he makes 3 of the 8. So in other words, the probability that X is 3. Here's where some of you who were in grade 12 pre-calc last year will recognize this, but you may not initially recognize the notation I give you. Yes?
How many, like here's 8.
Oh, it matters out of 8.
For the probably 3.
It doesn't have to be.
No, it's just, what's the probability that he makes 3? Yes. Okay, the question is, first, how many different ways can I make 3 shots out of 8?
You can just do your roll of 1.
There's a lot. It could be the first. It could be the first 3. It could be the first 2 and the 5th one. It could be the first one and the 4th and 5th one. There's a whole bunch of combinations. There's a whole bunch of combinations. What I need to find is how many ways can I make 3 from 8? How many ways can I make 3? So I've got 8. How many ways can I choose 3? The other notation for this means how many ways can I choose 3 from 8? Or another notation is out of 8, how many ways can I choose 3? That's maybe what you recognize. Now, you guys learned, and those in my pre-calc class this year will learn how to do this using a formula. But you don't need to, okay? You can actually use your graphing calculator that we'll talk about in a second. Actually, you're not even going to have to do this all this work. You're going to be able to use a graphing calculator function that does all of this for you. I just want to show you sort of the basic formula. So, remember, he's taking 8. This is telling me how many ways I can choose that he makes 3 from 8. That's the probability of success, right? How many times does that happen? No, 3. This is the probability of failure. How many times will this happen? 5, or 8 minus 3. So that's how we set it up. You figure out how many ways can you choose the random variable you're given from the fixed number of trials. Multiply that by the probability of the number of successes, which will be the same as this. And then multiply by the probability of failures, which will be the same as the total number minus this. And then if you did all this, this would work out to approximately 0.112 or about 11.2%. Yeah.
Maybe this doesn't matter. But on the previous question, P x equals 3 represented.
We're talking about 2 completely different distributions.
So P x equals 3 represented making it on the 3rd try. But on this one, it's making 3 of them.
Out of a fixed number that you're given.
So it doesn't. So it doesn't have like a set meaning. It depends on the whole form. You know, like because if you did like toasty can't say that always has a meaning.
That always has that.
A meaning. Like it means the same thing every single time.
Okay.
This doesn't. And that's
You're saying Px, you're talking about this.
Yes.
Yes, well, it depends whether you're talking about a geometric or a binomial distribution. I got you. Okay, thanks for sharing. Again, what are the 4 conditions? 3 are the same. The first, third, and last ones are all the same. Each trial is either a success or failure. The probability of A success on every trial is the same, independent, and the same. These kind of go hand in hand. However, instead of BIFs, I say bins because there's a preset number of trials. Geometric, you keep going. Where you look for your first success. Anyway, here's the formula that we just did. Again, you're given that, but you don't need it because we can use a graphing calculator. And it's the same setup.
This is PDF or C, the
PDF means we're finding a specific random value.
that's like permutation versus combination.
No,
No.
nothing to do with that. Yeah.
Just combinations in this.
Yes, no permutations.
It's just combination.
Yes. Okay, so if we went to the above, let's say we wanted to find, so we already got the answer above for when x is 3. We know that it's going to be about 11.2. Well, let's use the Binomial PDF function to clarify the answer. So second bars always gets you your two distributions. Scroll down until you see Binomial PDF. Notice there's 3 things you've got to enter. Not just the probability of success and the value of the variable, but how many trials there were. So you got to choose, and I should, you got to show in calculator speak too. So what you should be doing is this. Whoops. This is how you would show your work. Binomial PDF, and then fill in trials. There are 8. P success is 0.613, and X value is 3. You have to write that. So I should have written that in the geomet stuff too. Because that's basically showing your work.
Is it that PMC that's throwing off because of the permutation versus combination in the frame?
I understand.
Thank you. I appreciate it.
Okay. I just wasn't sure what else you wanted me to say. So I figured I'd say something, supportive. 8.613. Why does my voice always go whenever I have you guys? 3. And you get 0.1119 or 0.112. So you're going to get, so we confirm that you get the same thing. If we change the question slightly and said, what's the probability of making 3 or less? Then we would have to do this. And then we would have to change to Binomial CDF. When you think of C, I always think of P as point and C as cumulative. Because you're finding a range, a cumulative range. What's the probability of making 1 and 2 and 3? That's what this means. Everything else is the same. Trials, 8. P, 0.613. X value, 3. Do all that. And I suggest you try it on your calculator. You've got one here, or I just say the answer, just so you are comfortable with doing it. Go down. What you got? Yeah, 0.154. Or 15.4%. Yeah. This is where the way the question is asked could be a little tricky. Okay, we found this one on the previous page, right? We already found this one. 0.112 or 11.2%. We also found this, remember, that was px equals 3. We also found this one on the previous page. It was 0.154 or 15.4%. Here's where you gotta watch out with binomial ones. Is this one. What's the probability of making at least 4? How do I write that? At least 4. X is greater than or equal to 4. That's different. Binom CDF only recognizes less than. So how do I change this to a less than C? Actually, I can put less than or equal to, that's fine. Yes, you find the probability of less than or equal to 4, and then you subtract that from 1 to get greater than or equal to 4. That's all you do. So we've got to go 1 minus binom CDF. Trials is 8. Probability is still 0.613. X value, I got that. Doubting myself on that for a second. No, 4 or greater is part of this. It's got to be 3. It's got to be 3. Because here, remember, there's no 3.5 or 3.7. Here it's 4 or bigger. So what's the other situation besides 4 or bigger? 3 or less. That's why. Sorry, because I was double counting 4 if I put 4 there, and that doesn't make sense. So it's 3, and I get 1 minus binom CDF. So trials is 8. Oh, we've already actually calculated that one. That was 0.154. So 1 minus 0.154. Which makes sense. Because if there's a 15.4% chance that he makes it in 3 or less, that means 1 minus that probability must be 4 or greater. That only applies in the binomial one. It doesn't apply in the geometric one because it doesn't make sense. Because there's no fixed number of trials. It's impossible. You can't say what's the probability of him making it on at least his 3rd shot. Because I can't go 1 minus because it's infinite. There's no fixed trials, yeah.
Do you want us to show an average in decimal form? questions or they even? Or-
Decimal or percent? Decimal or percent? Does not matter.
Unless it's decimal.
Yes. Okay. So why didn't these guys stop? Why did these guys transition? This is why. Because it was all about their ego. I felt silly, felt like a sissy, Will Chamberlain said. So even though it was worse, he just couldn't do it. And somebody who never actually had to do it, but may have actually done better if he tried it, was Shaq. Right? Because he was known as a terrible free throw shooter. They used to foul him on purpose because the chances of him making a shot at the free throw line were way lower than live. But he refused too. He said, no way. I'm too cool for that. Okay,